Girls, if I differentiate this, I obviously get 6x, right? Yep. The process of integration is when you go back from that to that. And here's how you do it. So, girls, this is a symbol for integration. That symbol isn't introduced in this exercise, but I'd rather you girls get introduced to now. So if I want to find the antiderivative of this, we integrate 6x with respect to x. So you know how when you differentiate y, you're differentiating it in respect to x? Same thing, you're integrating 6x in respect to x. And the way you do it is you write the 6x down, but see how it's got a power of 1 right now? You always add 1 to that power, which is 2. And you always have to divide by that power. Okay? And then you always have to put plus c, and I'll explain that in a minute, where this represents a constant. So girls, the answer to integration of 6x is 6 over 2 is 3x squared and plus some constant. So as you can see, we got this part, but we don't know the plus 7. That's why we write plus c. This is the unknown unless we have more information given. That's why when we drew the antiderivative graphs, you know how I told you can have all sorts of graph along the y-axis? Yeah, that's why there's that plus c. That's the unknown. All right? So that's the process of integration. Add 1 to the power and then divide by that power. So let's do that as an example here. So if I want to find the antiderivative of that, this would just be plus 1 to 4 is 5. Put it over that power. Minus 3 plus 1 is 4. So that will be 4x 4 over 4. I'll simplify later. This one plus 1 to that is that. This one is going to be this. Now, this one, if it doesn't have a letter, you're just putting x next to it. Okay, that's the one little tricky thing, I think. You just...
Why didn't you do that for 7 then?
Sorry?
Because 7 is original.
Oh, no. We know that. That's original. Yeah, so if we're going backwards, we don't know that 7's there because when it gets differentiated, it disappears. So because we don't know that unknown, we just say plus c. All right? And then you always have to plus c to every integration question, antiderivative question. This is going to be 3. So there's your answer. Okay? All right. Now, let's have a look at some practical questions where we need to know plus c. Girls, I'm going to read the example, but let me summarize it for you. Let me read the question actually. The gradient is that. That's the gradient given. That's the equation of the gradient. Yep. If the curve passes through that point, find the equation. So they want you to find the equation for y. Okay? So this is the gradient. Keep that in mind. So that's the gradient given. And they want you to find the equation. Okay? Where that's the gradient. So, if I want to find the equation, which is y equals to something, that means I need to find the antiderivative of that. If you're going from the differentiated form to original form, that means you're integrating that. Okay? So let's integrate this. What do we get, girls? That's going to be 6x cubed over 3 plus, that's a 1. That's 8x squared over 2 plus c. Now, let's just simplify this. So we got y equals to... Now, this time, we can actually find plus c because we're given this point. That's my x, that's my y. Let's sub it in. So minus 3. So minus 3 is equal to 2 times 1 cubed. Girls, get what I'm doing? So, girls, if I work this out, you'll get c equals to minus 9. Okay? So my final equation, instead of having plus c, is minus 9. So the c really matters. So that's how you find the equation if you're given the gradient. You're going backwards. You integrate it and use the point to find c. All right. Let's have a look at another example here. All these questions I'm going through, calculus, mind you, is the biggest part in your trials and your future assessment. This is all accessible. And it's like one of those questions you can't ignore. They will always come up. All right, so we're given double differentiation is equal to that. One differentiation, if you substitute it in 1, is the same value as original if you substitute into minus 2 equals 0. Find the value when you substitute 3 into the original equation. So you know what? when you're going from this to nothing, you want to integrate it. So if I integrate this, I'm going to get differentiated once. Does that make sense? Yeah. Double differentiation, if I integrate once, that goes a step backwards. So if I integrate that, just quickly, oh, I did that wrong. Oops, my bad. Yep. So that's 3x squared plus 2x plus c. From here, I can find plus c because I'm given, if I substitute 1, what do I get? 0. So 3 times 1 squared plus 2 times 1 plus c. But what does all of this equal to? What does f dash 1 equal to? 0. So if I work backwards, that's 3 plus 2 plus c equals to 0. So c equals to? Okay, so let me just rewrite this. That's minus 5. Now I need to integrate it again in order to get to the original function, which is without the dash. So here, so f of x is equal to integration of 3x squared plus 2x minus 5 with respect to x. What's that? Yeah, plus c. And once again, this is my f of x. I can find c because I'm given, if I substitute minus 2, I get 0. So if I substitute minus 2, that means I'm doing this. What does that equal to? 0. Okay. I can't be bothered doing the calculation. Let me just look at the answer to see what that is. Minus 6. So, to finally answer the question, what's my question? What's the value if I substitute 3? That's 15. Okay? Do you get the process? All right. These are some exercise questions that I actually do want to touch upon. Let's have a look at the actual exercise question. Because this is important, you need to pay attention. When you want to integrate something to a really high power, what you do is basically just get that bit. But make sure you add 1 to the power, which is 5. Divide by that power. But you also need to get the differentiation of inside, which is 2. Okay? Now, but notice how there is an 8 in front though. You need to get that in as well. And then simplify that. So basically the answer is 8 over 10, which is, plus c. That's your answer. Okay, that's chain rule. So whenever you have a high power, do the same thing as what I've done. So you're going to write once again this out. What goes at the bottom with it? Differentiation of inside. 4x. Now you also have to get 8x there. No. That's just like a constant or some multiplier next to it. Because what happens is these guys actually cancel out.
Okay.
Plus c. Okay? That's chain rule. Apply the same thing though. Minus a half plus 1 is a half. Yeah. But you also got to divide by half, which is the same thing as just putting 2. Okay? If you're not sure, put in the calculator. This one, if you do minus 2 over 3 plus 1, that's what you're doing. You can just put 2 divided by 1 over 3 in the calculator, but it is just 6. Oops. 2x half plus 6x a third plus c. You can leave your answer like that, but in the book they may have the square root sign instead of the half. It's up to you. Okay? Now, 15 and 18 are the hard questions that I want to go through. Take a photo of this so I can rub half the board. Let me read it out. Girls, a curve, when you double differentiate, not just one differentiation, if you double differentiate, you get 8x. Now, and the tangent at a certain point has an angle of inclination at 45 degrees with the x-axis. Let me explain what that means. Let's say this is the point, minus 2 and 5, all right? And let's say at that point there is some curve. I have no idea what it looks. What they're saying is there is a tangent at that point, all right? Now that 45 degrees what it means is at that point is 45 degrees. The reason why they've given you that is because we need that angle to find the actual gradient value at that point. If you're given an angle, how do you find the gradient value at that point? Do you girls remember to find the gradient? And if you're given an angle, you do... You girls remember that?
No.
The reason why you do tan is because rise over run, opposite of adjacent. Yeah? You guys not remember that? Gradient is rise over run by definition. Trig ratio is also opposite of adjacent, which is rise over run. So whenever you're given an angle and you find the gradient, just put tan in front. So, tan 45. So the gradient is 1. Now, girls, let's just pause for a second. What are we trying to do in this question? We're trying to find the equation of the curve. So in the end, our goal is to find the equation where y equals to something. So, in order to do that, our first step, knowing these details, let's use it later. What are we going to do with this in order to get to that? I need to integrate this, right? So if I integrate 8x, that's 4x squared plus c. Right now, where am I at? Am I at y or dy over dx? Yeah. I need the c, but I can find it because... Well, tell me, how can I find it? Yeah, I'm given the point. Yeah, what's my point? Yeah, right now, I'm not going to use this y because I'm working with the gradient form right now, the differentiation. So right now, what I have is this. But what's my gradient at that point? I found out for you. The 1, that's right. Yeah? So c is equal to... So right now what I have... This is what I have right now, if I'm correct. Yeah. One more step. Now I've got to integrate it again to get to my final goal. Integrate this. So that's my y. How can I find c? Sub the points. So this one, it's got a really unique value. Girls, you with me? So it's okay to get fraction. So girls, this is how you do this problem. Expect this type of questions in the future. If I was making an exam and I wanted to put one of those harder questions, this would definitely be one of them. Just to give you as a guide, I want to also do question 18, but just as a guide. It's the same steps, but you girls need to be able to picture what I did up on the board. So let's say this is a tangent here. Let's say there is some curve. We obviously want to know the gradient at that point, but we're not given any angle, but we need to use this fact. So if what they're saying is this tangent is perpendicular to this. So what that means is this line is that. Does that make sense? So how would we find that red gradient or the value of the tangent gradient given that? Yeah, so we just need to make y the subject here to find the gradient of this line, reciprocate and put a minus, and that will get us the red line, right? Yeah, so let's just quickly do that. So y is equal to... So... Is that correct? Did I make any mistake? Yep. So the gradient of that black line is minus a half, so the gradient of the red line should be? 2. That's right. So now we're back to square one. Same steps as what I've done, just different numbers now. So this is how you set it up. Okay? All right, that's it from me, girls. Thanks.